All right, let's get started with DSMA 11. So this is the quadratic formula. What happens is we put an equation into standard form. You see that down here with the ax squared plus bx plus c equals 0. Same thing as what we did with factoring. Now the quadratic formula works all the time. It even works if you can factor, but what's great about it is it works if you can't factor. It will still help us find the solutions of a quadratic equation. So what's going to happen is we are going to grab the numbers in front of x squared, that'll be a, in front of x, that'll be b, and then the constant on the end is c, and we're literally going to plug them into this formula. So I will show you how all that works as we go along. We have to do a little bit of other work first. All right, here are a few links for you if you want to look at some YouTube videos for memorizing the quadratic formula, but you can go into YouTube and just type quadratic formula. You'll get some videos and songs to memorize that formula. Okay, we're going to take a quick look at radicals because for the quadratic formula, we're going to have to simplify radicals. Now, 144 is a perfect square. So if you put this into your calculator, what you're going to do is hit the shift key here and then hit the x squared. When you do that, you will get a radical with a box underneath, and you're able to put the 144 in there, and you see that we just get 12. And that's because 144 is a perfect square. If we end up in the quadratic formula having a perfect square, then we know we could have factored the quadratic equation. But if we don't have a perfect square, then we are going to have to simplify. All right, when we try to take the square root of a negative number, we are going to get an error. Until later in this section when we're going to move on to imaginary numbers. But for now, we are going to get an error. Now, don't forget, when you're using your calculator for a negative number, you're going to use the negative down here. And so you would again hit shift x squared and then put your negative 16 underneath. But for this one, we're going to say it's not a real number. That's because we do not have two numbers, or excuse me, we don't have a number that we can multiply times itself and get to negative 16 if we're staying in the real numbers. So that is a true statement that the expression is not a real number. All right, so let's look at simplifying radicals. Now we really like the Casio because the Casio will simplify radicals for you. You can actually put the whole quadratic formula into the Casio and it will take care of it for you. Some of the TIs will and some won't. You'll just have to check. And not all the Casios do, only the graphing calculators. So if you have a calculator that does not simplify radicals for you, let me show you what happens. So we take 54 and we're going to create a factoring tree here. So if we, let's see, 54 is divisible by 2. That would leave us 27. Then 27 is not divisible by 2, but it is divisible by 3. 9 is divisible by 3. And now we have our factors, right? 2 times 3 times 3 times 3 would get me back to 54. Now, because this is a square root, we want pairs of numbers. So any pairs of numbers can come out of the radical. Any numbers that are by themselves cannot come out from under the radical. So what's going to happen is this pair of 3's tells me that a 3 can come out from under the radical, but I still have the 2 times 3 inside. And so that would get me back to 3 times the square root of 6, which is the same thing that the calculator gave me. Now, another way of looking at this is that 54 is 9 times 6, and the square root of 9 is 3, but the 6 is not a perfect square, and so it would have to stay underneath. So this is called simplifying radicals. Again, this is why we like the Casio, because the Casio takes care of it for us. Let's look at another one here. All right, let's look at the square root of 40, and we want to simplify. So we're going to take 40. We're going to create a factoring tree here. It's divisible by 2, 20 is divisible by 2, and finally 10 is divisible by 2. But now I'm done. So 2 times 2 times 2 times 5 would get me back to 40. Now I want pairs, so only pairs of numbers can come out from under the radical. So in this case, that pair of 2's can come out from under the radical, but the 2 times 5 has to stay put. And so that's going to stay put underneath. Now, the other reason this works is under the radical, it's 4 times 10. And so the square root of 4 is 2. 10 is not a perfect square, and so it would have to stay put. All right, let's try a few more. All right, now you actually can pop this right into your Casio. It's going to give you the same answer, but we're going to do it by hand, just have a little practice. So the 3 is already outside of the radical. I'm not going to worry about that one, but I am going to break down 63. So let's see. 63 is not divisible by 2. It is divisible by 3, and that would give me 21. And then 21 is also divisible by 3, and that would give me 7. So 63 is 3 times 3 times 7. Since I want pairs, I can bring a 3 out from under the radical, but I already have a 3 here. So this is going to be 3 times, and then the 3 that I was able to bring out of the radical from over here, and then only the 7 would stay put. Right? That lone 7 has to stay under the radical. And so then if I finish that up, I get 9 times the square root of 7. All right, let me bring up the calculator and show you. Okay, so I put this in the calculator just like the original problem. I did 3 times the square root of 63, and it simplified for me and gave me the same answer. All right, we're going to try a few more. Because those of you who have a calculator that doesn't do this, you might want to go buy one or download the app or make trees. All right, so not divisible by 2. It is divisible by 3. And then I have 15. 15 is 3 times 5. All right, so I have a pair of 3's that I can bring out, and then this lone 5 has to stay put underneath. So hopefully these are starting to make a lot more sense to you. So right now we're just simplifying the radical. We're not worried about using the quadratic formula soon. All right, let's try the quadratic formula. So the problem is m squared minus m minus 2 equals 0. So we're good to go. We're in standard form. All of the terms are on one side and 0 on the other. That's very important, just like with factoring. So now we have to grab the a, b, and c. So in this case, in front of the m squared is going to be the a. So a is equal to 1. In front of the m is going to be b, but we do have to take the sign. So we're going to have b equal to -1 from right here. And then finally, c is on the end, and that's -2. So now we have to substitute that into this formula up here. So what we're going to do, the very first term always, now this is a giant fraction. Sometimes students forget to make the whole thing a fraction, but the whole thing is a big fraction. So if you're going to put it in your calculator, in the Casio, you're going to hit the fraction key first. All right, so the very first thing we're going to do is -b. Well, -b would be the negative of -1, right? Because b is -1, and we want the negative of that because that's what the formula shows me. All right, then we use this plus or minus. Now, you cannot use that plus or minus in the calculator. You have to just use plus and then go back in and go back up there and change the plus to minus to get the second term, or the second solution, excuse me. All right, then we're going to have a giant radical. The first thing we're going to do is b squared. Now, I always put the b in parentheses because if it's negative, it has to be in parentheses. If it's positive, it doesn't matter, but that way I just always use parentheses and I'm not going to make that mistake. Okay, the -4 is just always there, right? See up here, you can see you have -4. That is always going to be there. And now I need to multiply by a. Well, a over here is +1. And then I'm going to multiply by c, which is over here, which is -2. Okay. And then on the bottom, we always have the 2, but then we substitute in a. Well, a is +1 over here. So all we're doing is substituting. We're substituting the a equal to 1 wherever we see an a. So that is on the top here and on the bottom here. Then we substitute b in front of the radical and inside the radical. And of course, we square it. And then finally, c only shows up one place, and that's over here. Okay, so now we have to clean this up a little bit. So what we're going to do is we have m is equal to, well, the negative of -1 is +1, plus or minus, and then we have the square root. So inside the square root, we have 1. Let's do it over here. We have 1, and then -4 times -2 gives me a +8. And so therefore I have a 9 under the radical. Look at that, that's a perfect square. So we're going to take care of that in just a minute. And then finally all divided by 2. Okay, so if I take care of that perfect square now, I have +1 plus or minus 3 divided by 2. Now that's not how we answer problems. We want 2 solutions. So what we're going to do is come over here and we're going to do 1 minus 3 divided by 2. And we're also going to do 1 plus 3 divided by 2. So 1 minus 3 gives me -2, and then -2 over 2 would get me -1. Over here, 1 plus 3 is 4, and then 4 divided by 2 is equal to 2. So these are actually my solutions. Now the reason they're just 2 numbers and we actually had a perfect square is because we could have just factored this to begin with this problem. So we could have factored, we would have m plus 1 and m minus 2 all equal to 0. And so we would have found the -1 and the 2 very easily without even doing the quadratic formula. But it's good practice. Okay, so we can always use the quadratic formula, always, no matter what. We can't always factor. Sometimes we can factor, this one does factor, and then sometimes we have to use the quadratic formula. All right, let's try another one here. We have used the quadratic formula to solve the equation, and we have 1/4 x squared minus 2x minus 4 equals 0. Now we could put the fraction in there if you want. You could put the 1/4 in for a, you could change it to a decimal and use 0.25, but I think it's easier to get rid of fractions before we put it as the quadratic formula. And we can do that because this is an equation. So what I'm going to do is multiply everything by 4, both sides. So 4 times 1/4 would get me x squared. 4 times -2x would be -8x. And then 4 times -4 gives me -16, all equal to 0. Right, so now I don't have any fractions to mess with, but you have to multiply every single piece by the common denominator, which was 4. Okay, so now we can use the quadratic formula. We have that a is equal to 1, that's from right here. Remember, there's an implied 1 sitting there. B is equal to -8, and C is equal to -16. All right, so let's get to work here. So we have x is equal to, the very first thing we're going to put in here is negative of b. So that's the negative of -8. Then we use the plus or minus symbol. All right, now we have a radical. So we're always going to put b in parentheses to be on the safe side. So I've got negative 8 squared, right? That's just b squared. Then I always have minus 4. Okay, then I have a, which is 1, and I have c, which is negative 16. Okay, and then finally on the bottom, I have 2 times a, which is 1. All right, so let's see what that gives us. So the negative of negative 8 is positive 8. Let's come over here and take care of under the radical. So negative 8 squared is 64. Whoops, I didn't finish this. Negative 4 times negative 16 is also 64. So that gets me to 128. All right, so we are going to have to clean this up. So let's start breaking it down. So we have 2 with 64, 2 with 32. This is going to go on forever. Hopefully you guys can see this all the way over here. I don't know if I'm going to be able to show you anymore. All right, so we want pairs of 2s. So we have 2 here, 2 here, 2 here, and then I have 1 all by itself. All right, so let me put the 128 under here first. Okay, so for each set of 2s that come out, we're going to multiply. So 2 times 2 times 2 is going to give me 8 out front, but then that lone 2 is going to stay underneath, and then I'm going to divide everything by 2. Now here's the issue. When we start trying to simplify these, you cannot touch the radical. So anything under the radical has to stay put. You cannot simplify anything that's under the radical at this point. We have to leave it. But we can take 8 over 2, right? 8 over 2 is 4, and then plus or minus, and then we have 8 over 2 again, and then we're going to pull that square root of 2. So this is actually our answer right here. It's 4 plus or minus 4 times the square root of 2. And you're thinking, what kind of answer is that? Well, if we put it in our calculator and hit our FD key, you would see it's just a decimal. It's not a pretty decimal. It's what we call an irrational number. It's a decimal that goes on forever, but it is a decimal. And so this is the exact answer. Sometimes you'll see the answer separated, where you have 4 minus 4 times the square root of 2, comma, outside of the radical comma, and then 4 plus 4 times the square root of 2. So sometimes they're separate. My math lab usually lets you put the plus or minus in there, so hopefully for this one it does. I'm going to go ahead and show you on the next page how you can put this in the Casio. All right, so when you're putting this in the Casio, the first thing you have to hit is the fraction key, right? That's the very first thing you have to do. Then you're gonna start in the top. You have to make sure that you use a negative key where it's negative and subtraction where it's subtraction. So in this case, over here, your negatives are here, here, and here, but this one is subtraction. So that's very important. Otherwise, you're going to get a crazy answer. You get a crazy answer anyway, right? So if we do our fraction key first, and then we put the negative of negative 8, put a plus sign, because remember in the calculator, you can't do plus or minus. Then you're going to do your radical, and you're going to put b squared minus 4 times a times c. Then come out from under the radical, go down to the bottom, and put 2 times 1. When you do that, you get the 4 plus 4 times the square root of 2 like we got, but you only get the one answer. So then what you're going to do is use your arrow keys and arrow up, come back into the fraction, and change this plus sign that was in front of the radical to a subtraction. And when you do that, you'll get the other answer. You'll get 4 minus 4 times the square root of 2. Okay, so you cannot do the plus or minus together. You have to do them separate. So go ahead and put the plus sign first up here in your numerator. Find your answer with the plus sign, and then go back up, change that plus sign to a subtraction here, and go ahead and hit execute again, and then you'll get your second answer. So now you have both answers. I did also include up here, I just wanted you to see that when you hit the FD key and change these to a decimal, you can see that we actually have answers. There really are points on the x-axis. They're just not very pretty points, and so that's why we leave them in exact form until the very end. So it just depends. Like if you are my heart surgeon and you're trying to create a stent for me on a 3D printer, I want you to not round until the very end. I want you to keep the exact calculations until the very end, and then you can round a little. But if I'm building a deck on the back of my house and it's a deck on the ground, then I can round a little bit along the way, and it's not going to be so devastating if I'm off a little bit. All right, so we're going to head on to part 2.